Hello everyone, welcome back. So in this video, we are going to understand the Leetcode problem number 1594. It's a maximum non-negative product in matrix. Let's suppose what the question saying that we have to start from this position and you have to reach here. Okay. So the possible path is either it will come here, it will go like this, or it will come like this. Okay. So these are the path we have given. Okay, or any other possible path will be there. Okay, because this cell is nothing but 0 0 and this cell is nothing but m minus 1 comma n minus 1. So these are the two cells we have given. Okay, then we will take we have to find the path with the maximum non-product, right? Non-negative product. So the product of the path is the product of all the integer in the given cell, right? We have to visit along the path, right? Let's suppose it will move -1, -2, -3, -3. So these product we have to take and the -2. Like that we have to take the product and then we will think about it. Okay. Let's go ahead and understand. Then what the question is saying that it is saying that let's suppose these are the examples we have, right? So it is not possible to get the non-negative product in the path from 0 to 2, right? So return -1. So in this case not possible because all are -1. It is -1. In this path, this is the path. The shaded blue color is a path where if you do 1 into 1 you will get 1, then you will come to -2, you will get -2, then you will multiply -4, so -4, so 2 into 4 is 8, into 1 is equal to 1, you will get the answer 8. Okay, then in this there is no possibility, we'll multiply with a 0 and then -4, so it will give 0. So non-negative, in the case no negative value should come, but it should be the positive value, right? In this it is -1, so there is no possibility, will return -1. I hope you understand. So whenever we need to find the all possible paths, right, the condition is very known, right? So let's try to understand how we are going to solve the problem. So we have everything, right, needed that we need to solve this problem, right? So let me now build the thing that we should understand before writing the code. Okay, so the main thing we have here is the problem look like a DP, correct? Because the problem is a DP, so we need to track both maximum and min product at each cells. Let's suppose that we start from very beginning, right? So whenever we move to any cells, either we'll move to this cells, this cell, or this cell, right? Any cell. So at each cell, right, we need to find both the maximum and the minimum product, right, at each cell, at each cell. Okay, the very first thing we have to find it. Okay, because multiplying a large negative by another negative will give the positive value, right? So let's suppose some value we have, let's suppose in this case we'll take -3. Okay, and if we multiply with -3, what will it come? It will come positive value, right? Means 3 into 3 is 9, you will get, right? Similarly, if this is large value will be there, right, obviously it will come here large values, either of these two, because these two signs we have negative value, so it will give the positive value, but either of one is only one is there, it will give the negative value, right? So we have to think about also key how this will work, right? But basically at each cell you have to find the max value and the max and min product, right? And so we can find the large value. So this concept is there. Okay, now think that what is our goal we have here. Okay, so we have given the grid, we have given, right, and we have to travel from the 0 0 cells, right, the very first top left corner to the bottom right corner. Okay, so you can only move, right, either the right or the down, correct? Because this is the cell concept that will start from 0 0 and you have to go, either you will go the right step or the down step. So we have to find whose product of we have to find the path whose product of all the visited cells is the maximum non-negative value. Okay, so we have already seen how to find. Let's suppose in this case, if we multiply, we are getting -1, so we will return -1. Otherwise, if any positive value, that will return positive value greater than -1. Either 0 is there or any positive value will be there, right? So we have to return that. And if no non-negative exists, right, just return that -1 we have to return. Also, if any positive value comes, you have to take mod of 10 to the power 9 plus 7 as a mod value, right? So it will not go beyond the answer, okay, as a product. We also understood that we have to move the allowed moves are from any cells is either the right side, right, either the right side or the down side, right? So let's suppose if the current cell is I and J. If current cell is I and J, what is the next move? If it is moving the right side, right? So in the right, what will come? I will remain same, right? The row will remain same. Only J column will increase. J plus 1 will happen. For the down, that only J plus 1 will happen and the I plus 1 will happen and J will remain same, correct? So these two things you should also understand, because we should understand the move. This is your current cell. So current cell will at any at any cell, right, we have to find max and the mean of the product, right? So you should understand how we will move I and then J plus 1, I plus 1 and J. So this is the thing we have to understand. So there is a trick, right? It's a tricky twist we can say. Is that yeah, we can say that tricky twist, right? So there is a tricky twist that any negative value, if negative numbers are there, right? So a path, let's suppose a path with many negative numbers can flip to positive numbers, right? If any, let's suppose in this case, negatives are there, negatives are there, you are getting the positive value, right? And so you can't just track the max product, you must also track the mean, means the most negative value also. So that is why I'm saying take the max and mean product. So these things we have to understand. Now the critical module rule. So there is the concept we have is we have to take that modulo, right? Means you have to apply modulo only at the very end. Means not during the DP transitions, right? But you have to take that modulo on the intermediate products that destroy the comparison orders. Your negative becomes the wrong, right? So we have to take also means modulo on the intermediate products destroy the comparison order, means negative becomes the wrong value. Okay, so what is the code DP inside we have here? Let me clean it. Or itself we can, what we can say that like the DP, the main DP concept what we have here at each cell, right? Let's suppose cell is I and J, right? At each cell, right, what we have to track? We have to track, the very first thing is DP max. Okay, DP max, let's call I and J, right? So we will track the this one. Why? Because DP max will contain the large product. Understand? Then we should take another value is we can say DP mean, right? Similarly at I and J. This is for the smallest product. Okay, the two thing we have to use. Okay, now let's understand that. So let me show you the example. Okay, so we have example 2 where you can see we have given 1 minus 2 1 1 minus 2 minus 4 and 1. So this contains a path, right? So let's understand how this works in our case. So as you can see the example 2, right? What we have exactly here is, let's suppose we are talking about that we answer is 8, right? In example 2. Okay. So let's think that what is the best path we can say in this case. Understanding is very important. Okay. So let's start. The very first grid is 0 0. Okay. So from the 0 0, you will go to 1 0, right? The next cell. Okay. Down to this one, this cell I'm talking about. Okay. So we'll come to the 1 0. After the 1 0, we are going to where is 2 0, right? So we'll say, okay, you are going to 2 0, right? Then we will say that it is going to the next down, right? So down is what? The column is same, right? But the value is getting changed. Okay, so we'll say, okay, let's go with 2, we can keep, right? This one, 2 1, and then we'll go to the 2 2, we'll say that. So we'll reach like that. In this case, if we multiply, so at 0 0, you are 1, then we have is at 1, multiply 3, then 4, and into 1. Means totally you got is 12 left, sir. Let's see. So the base path we got is this one. So now let's trace all the path. What are the possible paths we have here in this case, right? So when we move here, right? So these are the grids value we have. How will set the path, okay, at each cell. Okay, so I'm talking about, let's suppose, yeah, so let's suppose that we'll create a DP. Okay, so we'll create like this. Okay, this is our DP, and we'll divide into 3 pieces first, like this. Okay, the very first that we have 1, so this is our start, correct? So from here, when we reach to at -2, right? What is the value we have? So 1 will say into -2. So we'll get some value here, right? Then we have is, let's suppose there we have is 1, right? So we'll say, okay, we'll multiply this -2 with this 1, correct? Then because we have to calculate at each cell, right? So this is called nothing but for the DP max I'm talking about. DP max means the here what we need to do, it is a largest product, we can say largest product, or yeah, largest product we can say. Then in the next cell what we have is, it will come, it is 1, so if you start from here and it will come down here, right? It means what we will get, 1 into 1. Here we got like this, right? We have moved from here to this cell, then this cell, like that we will calculate, right? Similarly, for this case, let's suppose it will come from here, right? We are getting 1 and the current value is -2, right? But some value is also coming here, right? So we'll say, okay, so we'll get here is 2 is coming and this value is going. So what is the max value will come here? Where, because see, from here it is coming -2 and for here it is coming 1. So 1 into the current value is 2, -2. -2 will get the -2. That will be the minimum value. So here 2 value we are getting -2, and another it is coming from the top down, right? So it is -2 into -2. We are getting the 4. So what we will say, this is our 4, right? And what is the minimum is here? We'll say, okay, so minimum value is nothing but -2. We can also store here somewhere, okay, because we need to track also. So in this case, when we'll come here, right, it is already having 4 here. So 4 into this one is, you'll get is 4, and from up it is coming minus. So we can leave for now, because 4 into 1 happens. So you will get, because 4 into 1 happened here, right? And this is 1. Okay, I think almost now. Let's suppose because we have choose here, the mean value is -1, -2, we can say. we have multiplied. Now think that we'll move here. So 1 will get from here, means we'll go 3 here, 1 into 3, like that. Then we'll get 8 here similarly. So the mean will say minus 4 will say similarly for the 8 answer will come, because it is coming from the up. Okay, means totally you understand the final answer you got is 8 answer here. So you need to find the best way how you can achieve this type of answer, right? So if you trace this, right, the very first that we know that it start into 1 into 1, right? Means it will start from here, right? But it will come where? It will come this place, right? We'll say okay, sorry. So this is the path, we'll say. Next we know that it will come what? 2 into 4 will get some value here, right? So this is 2 into what you call minus 4, we can say that will give you answer 8, right? So then we'll come to this place, right? We can say then it will come this, and the final answer is this. Like that you have to go, correct? Means if you write the path, what is the path will be there? Let me clean first. So here you will get is 1, give me a second, 1, then we'll go to the 1, then we'll go to the 1, then it will go to the minus 2, then it will go minus 4, and then we'll go 1, right? So you totally will get the answer 8. So this is our base path we have trace. Okay, so like that we have to find the path at each time, right? At each grid, and then you will find the answer. Okay, so now you understand that at each cell you need the dp max and the dp min, right? It means if I will say okay, the dp max that we will get, let's suppose at this 2 2 we will say, right? 2 2 at 2 2, right? So what is the dp max at 2 2, right? We are getting 8, right? So we need, what we need is 8 mod of, we can say 10 to the power 9 plus 7 we have to take, correct? Once this is done, you will get the value answer 8. So you will return this answer. This is our output. So the key thing is minus 2 is getting multiplied by minus 2 and getting multiplied by minus 4. Like that, it is the main key pair is here, right? With all the positive gives us the dp mean, which will flip to the max value as our answer, correct? So can we say that the your heart logic is what? Let's suppose we call this as a dp transition. This is our heart of the logic, right? Dp transition, what happens at each cell, right? Means we can say what happened at each cell, right? It means from the above, right? We'll say the from above what comes, right? The dp max I minus 1 and j. Another will come is from the left. What is coming from the left? There will be some value will be there. dp max, we can say that there will be some value is I and j minus 1. And this will give you two result at each cell, right? And what is that cell name? Is we are at current cell. At current cell, call I and j. So the value is, how will you get the value? Value at the current cell is grid value I and j, correct? And this is nothing but some value will be there. Some value will be there, right? So what I'm trying to say is, if you are at current cell, right? You are at current cell, right? You are getting some value from the above, means I minus 1 j, and from left is I and j minus 1, correct? So the DP transition, what is the exactly DP transition is, we have to compute the 4 candidate which comes from each time. So the possible candidates are something coming at DP max I minus 1 j, and this value will be get multiplied, right, at here, right, at with this position I'm talking about, right? This value will get multiplied with this value, right? So it is coming from the above, correct? Similarly, we say if it is coming from the left, I and j minus 1, and then we multiply by the v. But the thing is, we need to understand is it is multiplied the value, means the dp max value and the dp mean value. What is comes the minimum thing, right? What is the candidate value? What is coming from the above? What is coming from the down? Means mean minus dp max and dp mean, dp max and dp mean. The similar for the mean value. This is for the dp max value. Similarly for the dp mean value. Means total 4 candidates product will be there, right? Let me explain you how. So let's suppose that I'm talking about the transition, right? How the transition will work, how the transition will compute, right? So if you want to compute for candidate, you say candidate product, right? I will compute it. Very first is what are the candidates are there, right? So candidates are, we can say, is dp will get some max value and it is I minus 1, and that was a j, and the current value cell is v, comma, the value will come from the dp mean also. So dp mean, there will be I minus, which is also coming from the above one, right, above cell, and j, and it will also get multiplied by v. This will happen in the case of when it comes from the above, right? Similarly, dp max will happen, the value will remain same, right? The value is come from the left side. So the left side no need to change, just j minus 1 will happen, right? And the value again for the dp mean, right? So we'll say I and j minus 1, correct? And the v. So total, total we are talking about this one. These 4 are the conditions, 4 are the candidates, right? From where we have to compute the transition. It means if we want to find the dp max, right? dp max we can say, and I and j, right? Means we'll say the max between the candidates, max of the candidates, right? And the max candidate and the mean candidate. Mean candidate is what? That's called dp mean. Dp mean, we have some value I and j, right? So it is nothing but the mean candidate, right? So dp will max will go here and dp mean will go here, correct? Means similarly we're talking about, I have written at the wrong place. Correct. So if we'll say dp mean at I and j current value, what will come? Mean of candidates. Similar that dp mean for and dp max, you will calculate like this, correct? So the only we have to use is the what is comes from, if for this condition, what is comes from the up and what is comes from the this, right? So from the 4 condition you will use this 4, right? So why do we need to track the dp mean? Means we have to take the most negative value. If most negative value will there, right? If let's suppose v is negative, right, means some value will come, negative value, you if you multiply, it will give the new maximum positive value. So the negative into negative can give you the positive value, right? So that thing you have to also keep in mind. If the positive dp max is there and v multiplied, you have to also think about that, right? So these are the two possibility we have here. One more thing, that if we are talking about this v, right, so this v will also affect, its sign will also affect which candidate becomes a max and who candidate become mean, right? Let's think. If v is greater than 0, means it's a positive value, right? So what is the new max will come? New max means the old max, which one will give the old max, into the v, new mean, right? It will give you what? The old mean into v, correct? So in the positive cases, this will happen, right? If v is positive, right, means this is positive value we have, means new max is old max into v, right? It means the v that we have the mean value, right, it will give you the old mean value, correct? If v is less than 0, means it is negative value, right? So the new max will become what? Similar to this is old max, or say old max or old mean, we can say in this case our old mean into v, and this v is new mean, means what we will get is old max we will get into v, correct? Here we will get old mean, here we will get old max into v. Okay, so if I'll talk about the flow chart, how the flow chart will work, right? Let's suppose that initially what will happen is we'll take the dp max and dp mean, right? And the table is, we'll say m cross n we have, right? Very first, when you initialize this part, right, you initialize the dp mean and dp max and dp mean, right, in the tables, right? These two tables means we'll say, okay, dp max is 0 0 equal to dp mean 0 0. You will get the grid here, grid at 0 0, right? Then you will fill the first row, right? I will get the first row. First row is j equal to 1 n minus 1, like that you will go, correct? Means only one source you will take, the left and the dp max, dp mean and the previous grid, right? Means we are talking about the left dp max, you will find is dp mean, will say is nothing but the what is the previous value we have, previous into the grid at 0 and j, like that, correct? Similarly, you will fill, next is the first column, right? Let's call the fill the first column, right? Very first you fill this one, right? Once this is done, you will fill the first row, then you will fill the first column. First column you will fill, right? After this you will fill the first column, and the first column will come from where? I equal to 1, and you will go to the m minus till the m minus 1, right? I equal to 1, m minus 1 you will get. Okay, and you need the all the candidates that we have already talked about. 4 candidates are there, from where you will find. From here you will get the dp max, you will get, means the max candidate we have seen, right? Max candidate, remember, max candidates that you will find. Similarly, dp mean you will want, means the mean candidate. What is the mean candidate? That you will get it, right? After that, once you find the max and mean, it means for each cell you have to do this part. For each cell where I is greater than 1, j is also greater than equal to 1, we can say in both cases, then you will find this one. If we'll say is the dp max is, let's suppose m minus 1 and n minus 1, m minus 1 and n minus 1 is less than 0, If it is less than 0, so at this case, right, we will return the answer. Either we'll return -1, or either we'll return -1, or we will return the dp max value at m-1, n-1, or you can take the modulo 10 to the power 9 plus 7 also, and then you will return. So this is what our logic is. Understand? Let me tell you again. The very first thing what you need to do is you have to initialize the dp max, dp min on the grid given table m and n. Then you will find the dp max 0 0, like this you will take, right? You will assign. Then you'll find the first row, means j equal to 1, n-1 till n-1 will go, right? You will fill dp max, dp mean, previous value into current grid value. Then we will fill the column, first column. So I is equal to 1, and it will go to minus till the j-1 will go, right? And you will find the dp max, you will find, and dp mean you will find, how the max candidate and the mean candidate, and you will repeat this for all the cell, for each cell, right? And all the candidates you will continue keep finding the dp max, dp min. And once this is fine, right, you will need to return the dp max. If it is less than 0, you will return -1. Otherwise you will find some value, you can take the modulo of this one. So this is what you need to do, guys. If you are very good at dynamic programming, you can do easily and you can complete it. So as you can see, right, as I told you, very first you need to define these things, right? And dp min, dp max you will assign, right? And then you will call the dp max and dp min, you will start from the 0 0. Then you will fill the first row column, right? You will start filling that. Let's suppose dp 0 and j is there, so you will keep filling dp max, dp min, and you can get from where 0 to j-1, and will current value will multiply, means the value v. Similarly you will do for the top value, right? You will fill the same way, and for each cell, right, you need to get the value v, and you will multiply, right? You need to find the dp max and dp mean from the 4 candidate. What is the max value, what is the mean value, will find dp max and dp mean, right? That we have talked about. And then in the last you will return our max, dp max answer. If this answer is less than 0, right, you will return -1. Otherwise you will take the mod and you will return the answer. And this code is already accepted, as you can see, and you can try by yourself. If you have any doubt, you can ask me in the comment box. That's all I have in this video, guys. In case you are struggling with anything, please let me know in the comment section. This is a dp based problem, and I love to explain dp. Thank you so much. If you are struggling with learning DSA in the structured way, so you can prepare with ExpertFunda, so you can join my online classes. And that's all I have in this video. Thank you so much. Bye bye.